Good afternoon, sir. Today, becaLm Analytics is going to present to you the results of our analysis regarding the PetFinder Malaysia Adoption Prediction Project. To kick things off, I'll briefly provide a project overview. In the United States alone, 8 million cats and dogs enter animal shelters annually, and approximately 3 million are euthanized in the shelters due to overcrowding and lack of resources. Of those euthanized, 80% are considered to be healthy and adoptable. Animal homelessness and euthanization are not solely issues in the United States, but they're rampant problems worldwide. If shelters were able to find forever homes for the animals in their care in a more expedient manner, then innocent lives would be spared. To help increase adoption efficiency globally, becaLm Analytics has used data from Malaysia's leading animal welfare platform, PetFinder.my, to analyze animal and related profile features to determine which lead to faster adoptions. So before we get into the results of our analysis, let us provide you with further details about PetFinder.my. PetFinder Malaysia was founded in 2008 by co-founders Anda Ko and Eza Rachaga after they discovered a homeless, injured puppy, which they eventually named Chanel. They experienced firsthand the disorganization and misinformation regarding pet adoption in the country. They created PetFinder.my to serve as a comprehensive platform for animal shelters and individual rescuers alike to share information regarding homeless cats and dogs. Since its inception, more than 40,000 animals' lives have been saved through adoption from profiles placed on the site. Their organizational mission is to primarily provide a forum for rescuers to place ads about the animals that they find and to reach out to potential adopters so that these animals can have a home. The information that they provide within the pet profiles can include photographs, videos, and textual descriptions. So to help achieve their mission, PetFinder.my collaborated with Kaggle to create a competition seeking algorithms to predict the speeds at which pets are adopted based on their PetFinder.my profiles. Because adoption rates are correlated to the data contained within those online profiles, identifying features which lead to faster adoptions can help inform rescuers on how to craft an appealing and effective ad. Insights gleaned from the PetFinder.my data analysis can then be leveraged by shelters and rescuers globally with the hopes of increasing pet adoption rates worldwide. This leads us to our project objectives, where the primary objective is to educate animal rescuers on sound techniques to increase adoption rates. And this will be done by identifying significant animal and profile features which lead to faster adoption rates, constructing models to predict the adoption speed based upon available features, and providing recommendations on how to edit an ad to enhance adoption desirability. To help achieve these objectives, insights gained from our analysis were compiled and made accessible through an interactive and user-friendly dashboard, along with a cell phone application. Both the dashboard and the app will be demonstrated later in this presentation. One last thing before we dig into the results of our analysis. During the formation of our team, it was obvious that everyone involved had a special pet in their lives. In fact, this was the reason most of us were drawn to the subject matter to begin with. Everyone at some point had taken in a stray, rescue, dog, or cat. The name of our team pays homage to those pets by using the first letter from their names to form our team name. Ironically, the letters form the word becaLm, meaning to soothe or to calm, which is the effect that not only pets can have on their owners, but the impact potential owners can have on rescues and strays.
Next, we're going to take a deeper dive at the data used. Most of the data in the analysis was provided by PetFinder Malaysia, and it included tabular, text, and image data. So the tabular data was 24 different variables that were provided for each of the pets in the database. So most of this information was the specific breed, if any, of the pet. There was the color of the pet, age of the pet, the location that the pet was adopted, some health statistics, fees, things like that. The most important variable provided here was the target variable, the pet adoption speed, and this was broken into 5 different categories. A 0 meant that the pet was adopted the same day it was brought into the shelter. A 1 meant it was adopted in the first week. A 2 was adopted in the first month. A 3 was adopted in the first 3 months. A 4 was that there was no pet adoption within 100 days. So it either took longer than 100 days or the pet was not adopted at all. The text data provided was any sort of description about the pet. Some animals did have a short or long description given, and if the pet had a name, that was listed as well. The image data was over 58,000 image uploads of the pets, so some pets had multiple images available per pet. In terms of the quality of this data, there were no missing values in the primary categorical information that was given. So if a pet had 3 breeds listed, it might not have all 3 filled out, but the primary breed, the primary color, those all contained no missing values. And most of the data was categorical data. So we did look at the fee and age, some numerical data to check for outliers, but we did not find any significant outliers there. Before modeling, we did add more data and transform some of the current data in order to enhance the analysis. So becaLm Analytics did some feature engineering to add additional variables than the ones provided by PetFinder Malaysia. And this included some flag variables of whether or not the pet was given a name or a description, whether or not the pet had a fee. What we found what was more important than just the actual fee amount or any sort of specifics around the name and description was just the fact that a pet had or did not have those variables. So that's why we added those flag variables. There was also information that we built in, including population information about Malaysia that was tied to the location information given by PetFinder Malaysia as well. So we were able to add in the GDP and the population density of certain areas that was able to enhance the analysis. Obviously, more pets will be adopted in areas where there's a much larger population. We also added in information around the image features, and more details about this will be given later in the presentation. But as you can see on the pictures of the right, these are 3 examples of pictures that were provided by PetFinder Malaysia. The top 2 pictures are very clear and colorful as well as bright, and so these are some of the features that we were able to extract. However, the picture on the bottom, you can see it's much darker and it's harder to tell what the cat in the picture looks like. So features about this were added to the analysis, and again, more details will be given later in the presentation. In addition to the feature engineering, we also did some data transformation on the numerical data, such as the age of the pet and any fee associated with adopting the pet, in order to scale this information to be added in the modeling process. Next, we'll get into a brief introduction in the types of models used in this analysis. For this analysis, we looked at various multi-class classification algorithms in order to initially predict the speed that the pet would be adopted in the 5 different classifications ranging from same-day adoption to no adoption within the first 100 days. So the 7 models that we looked at included logistic regression, which outputs a probability that the pet will be adopted within a specific level of the classification speeds. We also looked at naive Bayes, which uses conditional probabilities in order to return the most likely speed classification. We looked at decision trees, which uses a tree structure of nodes and decisions that get you to a classification given certain inputs of speed of adoption. We also looked at extreme gradient boosting, which is similar to a decision tree, but also utilizes the gradient descent algorithm. We looked at random forest, which is a series of decision trees, which makes it much more flexible and averages those final decision trees to produce a predicted speed classification. We also looked at more sophisticated analyses such as neural networks, which consist of neurons and nodes, various layers of decisions in order to get to a speed of adoption classification. We also looked at doing convolutional neural networks for the image data to try to utilize the images in order to output a speed of adoption. We also looked at the k-nearest neighbor clustering algorithms, which is similar to the clustering process where the inputs, the classification is given based on how similar the input is to previously clustered pets in order to get that speed of adoption. So we looked at all 7 of these algorithms and evaluated them initially on accuracy in order to detect which algorithm is most useful at predicting the speed of adoption given our test and train data set. So we want to take a little bit of a deeper dive into our exploratory data analysis that was done in order to get more information on what features might be important to predicting the speed of adoption, as well as any variables that might be correlated with each other or have any outliers that need to be taken care of. So the target variable, the speed of adoption, was looked at especially closely. And so there are 5 different levels of speed of adoption, again ranging from the first day that the pet was brought in, it was adopted, to no adoption within 100 days. So you can see how the majority of the pets in our database were not adopted within 100 days, followed very closely by pets that were adopted within 8 to 30 days of being brought into a shelter or to a rescuer. The smallest category of data was same-day adoptions, those pets adopted within the first day, with less than 500 of the data points being ones that belonged to pets that were adopted within the first day. So in addition to looking at the adoption speed itself, we looked at other numerical data that compared to the adoption speed to look for any potential relationships with looking at the correlation between the different numerical variables here, as you can see on the picture on the right. So adoption speed is highlighted. There are not many features that are highly correlated with the speed of adoption. You can see how the fur length is a little bit more correlated. The color in the graph is a little bit more pigmented. Most of the relationships, though, are a somewhat negative correlation. That means that the relationship is inversely related. So if you increase one of the features, numerical features in this database here, it will decrease the speed of adoption. So this information is helpful to know. One, to know what features might we include in our modeling process, but 2, just to understand what features are important to that target variable that could be manipulated or taken advantage of with rescuers and shelters in order to help increase the speed of adoption. In addition to looking at the speed of adoption variable, we also broke out the data into data specific for cats versus data specific for dogs. So the findings of this was that on average, cats are adopted more quickly than dogs are, as you can see in the blue box and whisker chart on the right. Also, cream and white, as well as gray dogs, are adopted more quickly than any other color dog, such as black, brown, or golden yellow dogs. For cats, it is what's significant in our exploratory data analysis was that black cats are adopted less quickly than any other pet. So as you can see on the box and whisker chart on the right in orange, the black cats can have no adoption within the first 100 days, and that was not the case with any other color cat. Looking at the fees, cats and dogs there, cats with a fee are adopted more quickly, but there didn't seem to be much of a difference in terms of dog speed adoption when there was a fee or no fee.
For our preliminary modeling, we wanted to evaluate how well our models performed with our tabular data. To evaluate each model's performance, we examined the classification accuracy, as in how well the model was accurately able to predict the appropriate adoption speed classes, and other performance metrics such as precision, recall, and F1 score. As highlighted in the table below, we can see that our random forest model had a much greater accuracy score of 41% compared to other models that averaged around 30%. Our preliminary modeling showed us how well banking methods such as random forest perform compared to other well-known classification models. Here we're taking a look into the details of the random forest model's performance. Looking at the confusion matrix on the right, we can see that our model had an easier time to classify adoptions within 30 days and no adoptions within 100 days. Looking at our accuracy metrics graph across all the adoption classes, we can confirm that we see a similar behavior as what we saw in the confusion matrix. These metrics are much higher for the no adoption within 100 days and adoption within 1 to 7 and 8 to 30 days classes. This insight showed us that there may be features or relationships in the data that allow our model to correctly identify these categories. This result gravitated our modeling to classify between fast versus slow adoptions, where fast adoptions are animals adopted within 30 days, and slow adoptions are animals that are adopted within 3 months or more, instead of the 5 distinct classes. We felt that this made more sense since shelters can identify animals that may require more resources until their adoption and dedicate those resources to the slow adoptions. This also gives us the opportunity to investigate what makes an animal have a faster adoption and identify key features to help and recommendations for other pet profiles.
We will continue our preliminary model results by discussing the segmentation analysis. Continuing our preliminary results discussion, PetFinder Malaysia gave us many listings to analyze, almost 15,000. We determined it was important to understand the listings and attempt to group them into categories by performing cluster analysis. Described here are the 4 different algorithms that were used to determine the best segmentation classifications for the profiles: k-means, hierarchical clustering, PAM method, and model-based clustering. The analysis used all variables that were given from PetFinder Malaysia. No added variables were included as we needed to be sure the process could be repeated on new data to classify new pets. Ultimately, the k-means clustering algorithm performed the best for our dataset using 7 clusters. The chart on the left, the scree plot, indicates the within group sums of squares for each set of cluster samples. The results level out at 7, indicating not much improvement will be seen beyond 7 clusters. With more data or perhaps better disambiguation of the present data, we could improve the cluster results. But at this time, we're very satisfied with the results we were able to achieve. For a visual representation, we can plot the 7 clusters using the first 2 principal components. Principal component analysis is a statistical procedure that transforms the data set of possibly correlated values into a set of linearly uncorrelated values. Visually, the principal components are formed using all of the variables and essentially pressing them into a 2-dimensional plane, as seen here. These are just the first 2 principal components. There are many more that were created in the analysis, but these 2 account for the most variability and allow us to visually represent the multidimensional data. As you can see, there are 5 distinct clusters, with 2 clusters being overlapped by others. This could be due to the granularity of the image. We will discuss the distinct differences in the clusters next. Once our clusters were defined, we performed more exploratory data analysis to better understand what defined the individual segments. The cluster analysis can provide which group a data point belongs to, but it does not tell us how it came to that decision. Therefore, more analysis is needed to understand the segmentations. We have 7 clusters, which we have defined here and created easy to recognize names. Our most important clusters are the 2 with the fastest adoption speeds, clusters 3 and 6. These clusters, shelters with average listings and shelters with brief listings, provide us with the insight needed to identify the profile features that contribute to a fast adoption. Here, the profiles average between 2 and 5 photos with shorter, more concise descriptions. Both segments show a higher proportion of their profiles being associated with a shelter. This analysis has allowed us to better understand and classify new profiles and provide recommendations to help increase the adoption speed of new pets.
The saying of a picture is worth 1,000 words truly comes to shine when we are looking at our image data analysis. To use our images in our modeling, we extracted image characteristics from our images such as brightness, colorfulness, blurriness, whiteness, and image size. However, many animal profiles had multiple images, making it difficult to include all images on a given animal profile in our modeling. So we limited our image data to the first picture of every profile. We made the assumption that the first picture is what will actually capture a potential pet adopter's attention into clicking onto an animal's profile. Through our modeling, we discovered that image features greatly influence pet adoption speeds. For example, take a look at the two photos below. As we can see in the image of the cat is very dull and blurry, whereas the image of the dog is very sharp and clear. We also noticed that the cat has an adoption speed of 4, meaning the cat was adopted within 3 months, and the dog has an adoption speed of 2, meaning the dog was adopted within a week. Because of our image data analysis, we were able to represent these characteristics in our features. Low values of dullness and blurriness indicate that there is a high presence of those characteristics in the images. The image of the cat has a dullness score of 4.9 and blurriness score of 8.8, whereas the image of the dog has a dullness score of 15.8 and blurriness score of 364. Both photos are very different, and we can express those differences through these features, especially noticeable in our blurriness feature. We believe that the image characteristics have a great influence in how quickly an animal is adopted, and we will clearly see by how much later in our presentation.
So the next thing we want to take a look at was analyzing the text and the descriptions that were posted associated with each pet and start to understand if certain words or phrases were being used and associated with each breed and cats versus dogs, as well as understanding if any certain specific text that was used in each description could be associated with faster adoption speeds. So what we decided to do was, one, clean and stem our data using natural language processing, and then once we had all of our text cleaned and stemmed, to do a cluster analysis. So first I'm going to go through the very first step, which is pulling in all of our data for the descriptions, cleaning it and stemming it. We use Python in order to do this. So the first thing we did was we removed special characters, punctuation, and numbers. Then we got rid of words with a length less than 4. Then we got rid of all stop words, and we used NLTK. It's a package within Python in order to do this. The next thing we did was stemming. So we stemmed our words so that way they can collapse into each other when generating different counts and aggregating them up to do further analysis. So for example, that means the words president, presidential, and presidents would all have the same stem, preside. And what that allows is it kind of, when you piece back together sentences without the stop words and everything, they wouldn't quite read the same way, but what you're left with is the actual content of every sentence. So for example, vaccinated and healthy kitten and mother available for adoption at Pyongyang shelter. And then what's left after it's run through our NLP process is you can see below that it's almost like a shell of the sentence we had before. Everything is lowercase, everything is stemmed, and then all the stop words are removed. Now that we have all of our text cleaned and stemmed, and they all ran through, what we need to do next is, in order to do a cluster analysis, we need to determine the importance of each word relative to both each of the descriptions as well as the entire set of every description. So what we did here is we used TF IDF, and this is available in Python. So TF stands for term frequency, which is the frequency of each word within each description. IDF is the inverse document frequency, which measures the importance of a word, and it considers all of the terms and all of their equal importance. So you can see below that there are two examples. So I love dogs. I hate dogs and knitting. Knitting is my hobby and passion. So you can see below, term frequency simply counts how frequent each word appears within each document, or in our case, it would be each description. And then what TF-IDF does is it takes it one step further, and on a scale from 0 to 1, determines how important that word is to the entire data set. So you can see in our example below, love, hate, is, my, hobby, and passion all appear to be a higher importance to the entire data set as well as the individual description than and, knitting, dogs, and I. And this makes sense. And this actually shows why we get rid of stop words. So is, my, and I wouldn't even pass through our NLP process. And that would leave only the true core words and their stems to understand how their relative importance is. So the scores here would actually look even more different. So now on to our final results. You can see we had 8 clusters form, all with varying amounts of counts, and then we have our average adoption speed. So the top cluster was Vaccine Healthy Rescue, which had nearly 8,000 of our pets that fell into there. And this was almost a catch-all because all of the shelters that posted had put in the descriptions vaccine and healthy as well as rescue. So the majority of the descriptions fell into this cluster. The next largest one was found in healthy mother and kittens. So this told us that posters would post together in a group post for multiple pets, both the mother and the kittens, in order to keep them together specifically. The next cluster, Loving Family Friendly Rescue, which is interesting because the next cluster below it is similar but different, where the difference between all family-friendly rescues or loving family-friendly rescues is that this next one was specific to female rescue puppies. So there was a large cluster around specifically that group. The next was active, playful, toilet trained. So you can see there's a drop off in the count as well from clusters 4 to 5. The next one was microchip sweet forever puppies, and so there was a shelter that was posting just about microchip puppies and would use those words to associate with it, sweet and forever. Whereas the cluster above, active, playful, and toilet trained, more so related to kittens. So you can see the different words that are being used based off of dogs versus cats. And then the 7th cluster, cute, gentle, spayed, were words that were used by another shelter that was specifically words that were used with puppies and dogs. And then the last one is Penang shelter. There's a whole shelter in Malaysia that it formed its own cluster because they would put at the bottom, contact Penang shelter at, and then the phone number. And then, so everything that didn't fall into these other clusters kind of fell into those last 238 kind of fell into this cluster from that from that shelter. So all in all, we can see how the clusters broke out in different counts as well as the average adoption speed. So the active, playful, and toilet trained, and these were mostly around kittens. So you can see has the highest average adoption speed at 2.67, as well as the cute, gentle spayed, which was associated with dogs at 2.61, and then the lowest average adoption speed is found in healthy mother and kittens, with loving family-friendly rescue a bit distant behind as well. And then on the right-hand side, we can see a word cloud for all the descriptions for our fifth cluster, active, playful, and toilet trained. And what we can see here is, in order to make the word cloud visually make sense, we didn't use our stemmed and cleaned up data. We were able to understand which descriptions were associated with which cluster, append that back to our initial data set, and then able to grab all the text from all of those descriptions and then generate this visualization that you see on this slide here. And then we can see active, healthy, home, cat, dog. We can see all of that kind of being showcased here as well.
Aside from changing our adoption categories to fast versus slow adoptions, our final model includes our image features and cluster segments. In the table below, we present the top performing models which were run over a 10-fold cross-validation to see, on average, how can we expect accuracy results to vary in our models. Our random forest and XGBoost models were our best performing models, and it's very similar in terms of average accuracy score and standard deviation. However, in the end, we selected our random forest model as our final model due to its ease in implementation and simplicity. As previously mentioned, our image features greatly influence pet adoption speeds. We can see this in the feature importance snippet that image features such as image size, blurriness, and colorfulness are extremely important in classifying pet adoption categories. We also noticed that age, photo amounts, and our segmentation analysis clusters were beneficial for our model.
So, in conclusion, we found that identifying fast or slow predictions is much more meaningful than predicting adoption speeds based on 5 classes, which is what the initial data set had. So basically this allows for the shelters to then focus on which pets have a slow adoption speed and what they can do to make sure and push those pets up to the front so that way they will get adopted. And then our next finding was suggested that a profile's picture quantity as well as quality associated with a shelter versus that individual rescuer, and then as well as short and concise free text descriptions significantly helped adoption speeds. And that finding generally makes sense. When you go online, how more likely are you to purchase something if it has ample amount of pictures, as well as a description that makes sense. Especially with something like a pet. If there's a bunch of cute pictures of a pet, you're more likely to then, be pushed to then go into the shelter to then take a look for yourself, find out more, and meet that pet. And then lastly, through analysis of the random forest feature importance, it becomes clear that image features such as image size, colorfulness, blurriness, age, dullness, image height, and image width were the most influential predictors of adoption speed. So again, going off of the last point of how important the pictures were to the adoption speed, it makes sense that the size of the image, the colorfulness, and a lot of these traits go along with the adoption speed, with age being something that's not associated with the picture itself. And it just tells us that people are more likely to adopt a pet the younger they are, and that's something that obviously the shelters can't prevent. But knowing that a pet is of a higher age, now they know to make sure to put ample amount of pictures and make sure they can do it in as high quality as they can, as well as making sure those pictures are colorful, not blurry, and things like that.
In order to ensure the information was readily available and easy to understand for PetFinder Malaysia, the team created a series of dashboards and a mobile application displaying the insights that were discovered from our analysis. Our first dashboard contains information on our rescuer status, or the people creating the pet listings. The map shows the density of the pets, both available and adopted, as well as the pet type and the rescuer type. These three features can be filtered for both charts. The bottom chart represents the breakdown of the demonstrated adoption speed by rescuer type. The large shelters are indicative of a rescuer who has posted more than 50 listings. Small shelters have 5 to 49 listings, and individuals have created less than 5 listings and make up a majority of our contributors. There is a clear disparity in adoption speed by rescuer type, which we have previously mentioned in our presentation. The shelters have a higher rate of fast adoption speeds compared to the individual contributors. This dashboard will be important to monitor the relative success of our rescuers and the location of the pets. The fast adoption stats displays some key characteristics of our fast adoptions. This displays information on adopted pets only. All charts can be filtered by pet type and rescuer type. We have also included a selection to change the view of the adoption speed in the photo count and adoption fee chart from individual adoption speeds to fast versus slow adoptions. The photo count chart shows the relationship of the average photos provided to the adoption speed. Providing fewer but more pet-focused photos is key. Fast adoptions by breed shows cats in yellow and dogs in purple. The different breeds are represented in each bubble, and the total count of fast adopted pets defines the size of the bubble. The adoption fee chart shows the proportion of adopted pets and their speed based on if there is a fee or no fee. Our analysis has indicated that even a slight fee will help improve the quality of a posting. We want to continue to monitor this statistic. The results of the natural language processing are displayed here as well. We have indicated in blue those clusters that are associated with fast adoption speeds. As the data is updated, we will continue to monitor these charts to show the contributing factors to a fast adoption. The profile status will show the current status of our listings by adoption speed. We are only displaying fast versus slow adoptions as our focus is on the available pets for this dashboard. However, you can filter by the adopted pets to see how they have been performing. The available pets will show our predictions for fast or slow adoptions for the profiles. We want to monitor how many pets are available and their associated predicted adoption speed, which is displayed in the first chart. We also break it down by if it is an individual poster or a large or small shelter. The bottom section of the dashboard has taken the top 5 variables based on our predictive model's feature important results and displayed the current status here. We want to continue to monitor these as our profiles improve in the event that we need to adjust our recommendations for profiles. This dashboard will also serve as a quick visualization for our current available pets to show where improvements can be made in their profiles.
Our final dashboard, Target Profiles, is perhaps our most important and actionable. This chart shows those pets that have been identified as potential slow adoptions. We have summarized some key information, such as the pet type, breed, and gender of the pet. This chart can be filtered by location, rescuer type, and pet type. Based on our analysis, we have provided the key factors that contribute to a slow adoption profile. Any variables whose value fall outside our recommendations are highlighted in red to make it easier to identify the issues with the profile. Ultimately, we are recommending that the images be less than 26,000 square pixels and are not blurry. We also recommend that at least 2 photos be used and no more than 8 photos. The descriptions should be approximately 500 characters long. This dashboard will be available for download so that PetFinder Malaysia can contact the individual contributors to help improve their profiles based on our recommendations. We recommend that PetFinder Malaysia downloads this dashboard as soon as new data become available so they are able to act quickly on possible problem profiles. We want to ensure that their resources are being used on the right pets. We will now demonstrate the mobile application that was created for PetFinder Malaysia. On the home screen, you'll find the different features that are included in the app, which include the dashboards that were created and profile recommendations and information about the team. Our first dashboard, the rescuer status, is the same as what was displayed earlier. This one is fully interactive. You can filter the rescuer type to choose the different sizes, the pet types for cat and dog, and if the pet is available or adopted. The map is displayed here and is fully interactive, as you can hover over the individual states to see how many pets are in those different locations. They are also colored based on the density of pets in those states. The rescuer type adoption speed chart is below as well. We've added the feature that allows us to change the adoption speed category between slow and fast versus the individual categories displayed below. So see, we can change it so we can see now instead the fast versus slow adoptions for the individual rescuer types. Our second dashboard, the Fast Adoption Stats dashboard, is just as we displayed it earlier in the presentation. This one is fully interactive. Again, you can filter by the rescuer type and the pet type, but we also have the option to change from slow and fast adoption to the individual adoption speeds displayed here. So you can really see the impact of those average photos on each of the different adoption speeds. We also have the fast adoptions by breed. Cat and dog are the individual colors here. If you hover over a bubble, you're able to tell the different number of pets that are domestic short hair. In this case, there are 2,386 for this particular bubble. So more information is provided as you hover over each bubble. The adoption fee is important to include here as well. We had come to the conclusion that having even just a small fee is enough to encourage the adoption of a pet. So we want to continue to monitor this progress as time progresses. For our NLP cluster adoption speeds, we also included that information to be monitored here as well. So we can see that those in blue are associated with a fast adoption speed and those in orange are more associated with the slower adoption speeds based on the descriptions. Moving on to our profile status application. As you can see here, this will display information on our adopted and available pets. You can filter that by adopted or available. However, our main focus for this particular dashboard needs to be on the available pets. The available pets here show which, if they're in a shelter, they're posted by individuals. If they're flagged as slow, what kind of pet that is, and how, if they're flagged as fast, we have the number of counts of each of those pet types and the location of where they're at. These were, again, the top 5 features based on our feature importance from the model. So we want to continue to monitor these as the time progresses to show, okay, that our slows are more blurry, our fasts are more clearer images, and we want to get that to our individual contributors, the importance of making sure that these particular features are in line with our recommendations. Speaking of recommendations, we have also provided a page of all of our profile recommendations for the individual contributors and the shelters even. We want to make sure that our pets are being adopted as quickly as possible so as to eliminate any burden that we may have on the shelters or individuals. Our profile recommendations here include photos, the number of photos, the size of the photos, making sure they're clear and not blurry. We also recommend that they post individual profiles if they have a litter. Those are usually grouped together in one profile. However, if they have to post them together, we recommend using individual photos for each pet. The descriptions need to be concise and descriptive, but they need to be approximately 500 characters. As stated earlier, we noted that there were faster adoptions when they were associated with shelters. However, we can't expect every dog and cat to be placed in a shelter. This would overburden those shelters very quickly. However, if there could be some way to associate those individual contributors with a shelter so that they can increase the online traffic of those individual profiles. We also provided some information about the team for becaLm Analytics. As it states, we were formed with a mutual passion for rescuing animals. Displayed here are all of our individual pets and our continued inspiration. The names of all these pets actually help form our becaLm team name. So just wanted to provide some good information for PetFinder Malaysia about the team and why this is such a passionate project that we have been pursuing.
Several of the insights gained from completing this PetFinder Malaysia project has led becaLm Analytics to suggest the following recommendations and areas for future work and can be segregated into 3 main categories. The first being to intelligently utilize limited shelter resources. Shelter resources such as funding, physical space, and volunteer time are typically scarce. This in turn contributes to an environment where adoptable pets are possibly euthanized because the means to take care of them until they are adopted are not accessible. As such, shelters need to intelligently apply and use available resources. And to assist in doing this, we recommend, first and foremost, using our prediction model to classify the pets as having either fast or slow adoptions, and to allocate more resources towards those being marked as slow. We also suggest creating a time series forecasting model that will help predict the number of pets that will be put up for adoption in each shelter to allow them to better plan on how to allocate those resources. And then finally, we suggest allowing individual rescuers to post through an associated shelter via digital platforms so that the pet visibility is increased without creating additional resource burden on the shelters. The second category is updating the designs of the PetFinder.my digital platforms. The current design of both the website and cell phone app are not user-friendly and not designed in an attractive way. We strongly encourage PetFinder.my to invest resources into updating all of the digital platforms to be more appealing and easier to use. We also recommend, again, using our prediction model to classify the pets as having fast or slow adoptions and highlighting and featuring those with slow adoption speeds more frequently on those digital platforms so that they aren't as overlooked. And we also highly suggest creating guidelines and recommendations for when creating a post. For the image data, we suggest creating a model that would grade any uploaded pet picture and provide suggestions on how to improve the picture and ultimately the adoption speed. And for the free text descriptions, we suggest creating standards or even a specific form to ensure meaningful, more consistently styled descriptions. And the last area is to improve the quantity and quality of data. The data used in this analysis was limited to the Kaggle training dataset of only roughly 15,000 observations. This limitation to data accessibility and to provided data structure restricted the analyses conducted by becaLm Analytics. So we have the following recommendations regarding the data. First, to obtain more data to assist with the model analyses and evaluations, and to ultimately boost model performance. To track the data per pet instead of groups of pets to allow for further analysis on feature importance, and to obtain data beyond just PetFinder Malaysia to increase the opportunity to make a global impact on pet adoption speeds. In conclusion, given the analysis and modeling work conducted to date, the becaLm Analytics team believes that it has provided insightful and useful models and digital platforms which can positively impact pet adoption speed. With this information, along with our recommendations, Malaysia's PetFinder.my should be able to make decisions that not only lead to quicker animal adoptions, but ultimately reduce the number of innocent cats and dogs euthanized in Malaysia. It is our sincere hope that our work informs how to improve adoption rates globally. Thank you for your time.